Good day students, we are moving to module 4. Module 4 includes cables and suspension bridges. So first of all we need to know what is cable. Cables are deformable structures which are mainly used to support suspension bridges, roofs, etc. and are used in transmission lines. Okay, you can see the cables in a suspension bridge. This is the roadway area and this is the waterway area. These are the two towers. Okay, these two are the towers. It is supported by a cable. Okay, this is the cables are connected to the roadway through the suspenders. And this is the anterior cable. These two ends, the end cables are known as the anterior cables, and this is the roadway. So these are the cables. Okay. And this is the main span between the towers, that is the main span, and below the ground level it is the waterway. Okay, so these are the cables. Cables take only tension. Okay, they take only tension. Since they are flexible, the bending moment is 0. Bending moment is always 0. They do not take any bending moment. They take only the tensile forces. Also, the cables, anchor cables are provided, or anterior cables are provided to reduce the bending moment in the towers. Also, cables resist only load only by tension. They develop horizontal thrust at the supports. So here there will be a horizontal thrust. Okay, there will be reactions at the support. If this is the point A, there will be reactions RA, and if this is B, RB. Along with that, there will be a horizontal thrust. A suspension bridge consists of two cables. Suspension bridge consists of two cables which are stretched over the span to be bridged. Each cable passing over two towers is anchored by backstays to a firm foundation. Central sag or dip of the cable varies from 1/10 to 1/15 of the span. Central dip, that is this value. Central dip, or this is the central dip, or the sag of the cable varies from 1/10 to 1/15 of the span. A suspension bridge is generally preferred where its span is more than 200 meters for a roadway or 300 meters for a light traffic way. Now we'll see the equilibrium of the cable. How do we do the analysis of the cable when it is subjected to a system of concentrated forces? Suppose this is a cable. It is subjected to concentrated loads W1, W3, W2, W3, etc. A and B, it is supported. So A, there is a vertical reaction, and at B there is a vertical reaction, and there is a horizontal thrust at the ends A and B. Okay, so W1 is acting at a distance A1, W2 is acting at a distance A2 from A, and we are considering a central section at a distance X from A, and the maximum dip is Y. So now we are going to see sigma M about X is equal to 0. That is at this section. M about X is equal to 0. Okay, moment about X is equal to 0. You will get it as VA into X minus H into Y, H into Y dip, plus W1 into this distance, that is X minus A1, plus W2 into this distance, that is X minus A2, is equal to 0. So you will get from this HY is equal to VA into X minus W into W1 into X minus A1 plus W2 into X minus A2. Okay, this term is the beam moment. Isn't it? This term is the beam moment. Up to this point, what is the moment? That is VA into X minus W1 into X minus A1 minus W2 into X minus A2. So this is the equilibrium equation for a cable. So we are going to consider a cable of span L spanning a horizontal gap small l subjected to concentrated loads W1, W2, W3 as shown in the figure. So Y1, Y2 and Y3 be the displacement at the point 1, 2 and 3. That is the dip. Okay. The central sag or the dip at the points. And VA and VB be the vertical reactions and H be the horizontal thrust. So from equilibrium equation we have H into Y is equal to bending moment of the beam or M of the beam. So from that you can find out the dips as or Y1, Y2, Y3 as moment about of the corresponding beam divided by the horizontal thrust. From this equation you can calculate the tensions. So this will be in this cable let T1 be the tension, in this cable let T2 be the tension, in this cable T3 and in this cable T4. So deflected shape will be the similar to the beam bending moment moment diagram, and if M1, M2 and M3 are the moments at the point 1, 2 and 3, you can find out the deflections. Y1 is equal to M1 by H, Y2 is equal to M2 by H and Y3 is equal to M3 by H. So these from this equations you will get the deflections or the dips. From that dips you can calculate the tension value and also the length of the cable.